Hi, everyone, and welcome to EnergyLab's 2024 Climate Solutions Accelerator Showcase. I'm Beryl, and I am the program lead. I've had the privilege of working with the founders that you'll hear from today, who have made up our 2024 Accelerator cohort, and what an incredible group they are. Between them, they're working on tackling climate change from a range of emission sources, from industrial heat to passive cooling solutions and energy storage to electric aviation. So what we hope to demonstrate in today's showcase is that world-class climate tech startups are being founded here in Australia, and when they scale, they'll have a huge positive impact on the planet. Before we get stuck in, I would like to acknowledge the traditional owners of the various lands that we're dialing in from today. From EnergyLab's base, the Gadigal people of the Eora Nation, and I pay my respects to the elders past, present, and emerging. We also celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters. So today we're going to have some live demos. We're going to see a bit of tech, and importantly, you, the audience, are going to have a chance to have your questions answered live by the founders. So some of you may be wondering, how did these startups end up here in the first place, and what actually happens in our accelerator program? So back in March, we screened hundreds of startups, reviewed over 100 applications, and decided on a final 20 startups to pitch to our group of angel investors for a place in the program. It was these angel investors who made the final call on the 10 startups that are participating in this year's program. Throughout the last 6 months, we've pulled together our founder alumni, mentors, industry partners, and investors to help the founders build connections and facilitate knowledge sharing in a really structured and purposeful way. I know many people in our support networks are watching, so I'll take the opportunity to say a huge thank you to everyone who has offered their time and supported our program, and of course to the angel investors who back our program. Without all of that support, this program simply wouldn't be possible. I'd also love to take the opportunity to thank the founders. They have been truly awesome to work with this year. They've been incredibly committed throughout the program and really openly shared their successes, struggles, and advice with each other. It's really come together to be a wonderfully supportive cohort. They've grabbed every opportunity with both hands and have been just all around great company. Luckily for our viewers today, you'll get to meet these founders shortly. These are the people that are fighting the good fight and putting in the hard yards to help us reach our decarbonisation goals. I'm now going to hand over to EnergyLab's CEO, Megan Fisher, who's going to share a bit more about EnergyLab and our mission and what's been happening with us this year.
Thanks, Beryl, and thanks to everyone for joining us today. Since 2017, EnergyLab has been focused on our mission of reaching net zero by supporting founders with technologies and solutions that battle the global climate crisis. And over the last 2 years, we've really expanded our programs and now offer 8 different programs that support aspiring founders and startups, all the way from ideation to scaling and through to international expansion. Plus, we have 2 additional programs under the banner of Supercharge Australia, a joint program with our global partner, New Energy Nexus, that's focused on building the startup innovation ecosystem along the lithium battery value chain in Australia. We support these programs with expertise, as Beryl mentioned, from our network, and we have over 400 amazing mentors, almost 400 alumni, and with early stage funding support from our 200-strong EnergyLab Angels group. As 2024 comes to a close, I really wanted to reflect on progress and why the startups you're about to hear from are building solutions essential for meeting our global climate targets. A few months back, the International Energy Agency updated the Tracking Clean Energy Progress Assessment, where they track 50 different components essential for the clean transition. 3 of those components are now considered on track: solar PV, electric vehicles, and lighting, while there are still 47 components with the status of more effort needed or not on track, including renewables, data centres, grid-scale storage, aviation, steel, and innovation. And a little closer to home, according to the Australian Climate Change Authority, emissions fell by 3 metric tonnes of carbon in 23-24. They need to fall by an average of 15 metric tonnes per year for the next 6 years to reach our 2030 target. That's a sustained increase of 5 times last year's outcome. Their recent report calls for a faster rollout of renewables and more action from other sectors, such as industry, transport, agriculture, and the built environment in order to meet these targets. So progress is being made, but we need to move faster and we need to cover more sectors. The group of high potential founders you're about to meet are doing just that, covering a broad range of climate tech, including industrial heat, solar efficiency, electric aviation, passive cooling, and water treatment. They are ready to scale. And with the help of you all on the call today, we can support them to do exactly that. So thank you very much for your time, and back to you, Beryl.
Thank you so much, Megan. Before we dive into the presentations, I'll just explain how it'll run today. So we'll bring up the cohort one by one. This will give a snapshot. They'll give a snapshot of their startup. We might even see some products in action today. We'll also answer your questions live. So they'll have 5 minutes to present, and then we'll have 3 minutes for question time. So if you have any questions for any of the founders, please drop them in the Q&A box as they come to mind. We'll select a few to answer live, and any questions that we don't get to, the founders will answer by typing a response. So let's get to the good stuff. First off, I'd love to invite Andy Hill, co-founder and CEO at Planet Price. Hi, Andy. Thanks so much for kicking us off today. Over to you to give us an overview of Planet Price.
Thanks, Beryl. Thanks, everybody. Yeah, so I'm Andy Hill, founder of Planet Price. We help asset-intensive companies reduce the footprint of their supply chain on the planet by quantifying the environmental impact of everything that they purchase as a single financial metric, or what we call the Planet Price. So let me show you how that works. So jumping into the platform, the starting point for us is we take hundreds of thousands of purchasing transactions out of corporate systems. So what you're seeing here is a fictitious mining company. They spend billions of dollars a year, and this is all of the purchasing data that we pull out of their system. So you can see they're buying heavy truck tires. What we've been able to crack this year, and only actually in the first quarter of this year, is something I've been working on for 20 years, which is how can we use AI to automatically understand purchasing descriptions and turn them into environmental impacts. So what you can see here is the purchase order descriptions, the amount of money that they're spending, and then it's been mapped to an industry, and from that it's been mapped to environmental impact databases, and that allows us to calculate a whole variety of impacts. So obviously global warming in terms of tons of CO2, but also pollution and other factors. So the AI does that for every single transaction. And then what we're able to do is calculate the Planet Price for an entire organization in literally only a few hours. So this mining company spends 1.2 million. Whoops. All right. I've zoomed in. I shouldn't have done that. 1 second, please. Sorry, I'm just going to unshare a sec. And do that again. Sorry for that. I'm back. So we spent $1.2 billion per year, everything needed to support this mining company. And what we've done is we've calculated a Planet Price here of 201 million. So the way to think about that is this is all of the environmental impact resulting from those mining operations. And it's sort of like the financial impact in shadow terms. So obviously the one that most of our clients are interested in straight away, because they now have to report on this starting next year, is global warming. So for this mining company, their operations represent 524,000 tons of CO2 equivalents. But we go further than that. We also calculate water, 20 million meters cubed of water taken out of the biosphere, 82 million meters squared of land occupation, and also a whole variety of other pollution measures. We believe we're the only company in the world that's able to do this and to calculate impacts across the whole planetary boundaries model, which you may be familiar with. So this allows organizations to straight away understand their overall impact, and then they can start to drill into the data to understand where the hotspots are. So here we're seeing their entire procurement. We can see they spend a lot of money on diesel fuel, truck tires, cement, and so on. The color is representing the intensity of the planet price. Moving further on, we can start to look for opportunities to reduce their global warming. So if we look at these bubbles here, the size of a bubble represents the tons of CO2. So you can see there's 44,000 tons of CO2 equivalent from cement or lime. And then what they can do is they can drill in and understand who are the suppliers that are supplying that. So very quickly, they're able to identify hotspots, identify suppliers in their supply chain that they need to work with. So all of this is using AI to process purchasing spend data, but what we have also built is a life cycle assessment tool that works at a product level. So we're looking at materials, we're looking at transportation and so on. But what we found this year is it's quite hard for companies to find that data. They don't typically have that data easily available. So the question we asked ourselves was, could we use AI to do the same thing? So what I'd like to show you today is the first time we've ever demonstrated this. So I'm a little bit scared. This literally came out yesterday from our development team. But this is Sira. This is our AI assistant that does rapid life cycle analysis. So suppose, for example, I had bought chairs from Officeworks. Literally, all I have to do now is I can type in a description, an ergonomic chair. If I want, I can upload a photo. So I've got a photo of an office chair here. And then basically the AI will run and it will calculate what are the components in this chair, what are the materials that make it up, where is it manufactured. It will attempt to calculate that, and then it will come back with the planet price and show you what's driving that planet price for the chair. So it's gone through, it's calculated a planet price of $40 for this office chair. It's estimated a mass of 13 kilograms. And remember, all I gave it is just 2 words and a photo. So if we had more information, it would do a much more accurate job. But then what we can do is we can start to look at it and it says, we have a seat and a backrest, we've got the wheels and the parts and so on. And we're starting to get a heat chart of what's driving that planet price. So it's estimated the mass of each one of the materials. I can look at it from a planet price point of view, and we can see that the base and the mechanism is the largest part of the planet price there. And then transportation. So you can see it's analyzed the supply chain, raw materials to the manufacturing site, factory to port, shipping, and so on. From a distance point of view, it's going by ocean, so it's going furthest. But actually, if we look at the planet price, the shipping is very efficient. And the shipping is, what is it? It's only 16 cents. No, sorry, it is a little bit less.
Andy,
15
I'm
cents.
just going to jump in here.
Yep.
Andy, thank you so much. Brilliant. Thank you. It is incredible to see the platform live in action and to see what kind of granularity you can get into there as well. That's really incredible. Andy, we've had a few questions come in from the audience. We are a little bit over time, so I'm just going to ask one question and then I'll ask you to respond to the others just by typing a comment. But Arnie has asked, can a mining company benchmark themselves with another mining company or other mining companies if they want to?
Yes, absolutely. So one of the things we'd do would be planet price per ton. And so, you know, if you were going to benchmark two copper companies, for example, they could understand their planet price per ton, or at a much more granular level as well. Actually, we've also done that for councils, and it's interesting. What they benchmark themselves on is per resident. So it's almost like you get the rates bill from Brisbane City Council, and then you get the planet price bill as well, which represents the planet price for that council.
Fantastic. Andy, unfortunately, that's all we have time for today. Thank you so much for kicking us off today.
Have a great day. See you, bye.
Brilliant. So next up, I'd love to invite Dill from Dewpoint Innovations to tell us a bit about Dewpoint. Looks like the screen's just loading. Dill, it looks like your screen's just loading. Hey, Dill.
Hi. I love how it always does this.
No worries.
Cool. Okay, back again. I will share a little bit about what Dewpoint is doing in terms of using novel paint tech to address some of the biggest climate issues in the world. So I guess the three sort of key drivers for what we do is increasing heat, especially urban heat island effects, which are basically happening all over the world. Cities can be 7% hotter than rural environments, and that sort of impacts our health, but also the built environment. On top of that, we have water scarcity, where the world is going to have huge water stress and water shortage issues. The solutions to these problems are currently quite energy intensive, especially when you look at air conditioning units, which are used for cooling homes and businesses. They account for 10% of global energy use. And apparently by 2050, that's expected to triple in Southeast Asia alone. So our solution is to address this with something as simple as paint and something that we have developed to not only address the cooling elements of the built environment, but also help provide water securities in areas where we might have water shortages. We are a spin out from the University of Sydney, and we have developed a unique system to not only achieve passive cooling, but also water collection from the atmosphere in the right conditions. So this is a world first because there's no other cooling paint technology that can capture water. We also achieved cooling through solar factors up to 90%, but also with thermal emittance up to 95%, which is a bit more than what's on the market in terms of cooling paint. The additional element of water capture, obviously in the right environment with heat and humidity, we can capture dew with an easy roll off and can go into an existing water or rain harvesting tools that you might be using at home. I guess the benefit of what we're doing over traditional white paint, which is the question we get asked a lot, and any other cool paint that's on the market, is that we're not only reducing cost through reducing the need for air conditioning units or other HVAC, we can also reduce the surface temperature from black roof, for example, by 30 degrees, but it's also low cost and passive, so no energy is required. And the fact that we can apply it through one or two coats, and it's also self-cleaning because of the water capture, we also further reduce cost in terms of applying it as well. So having a passive water source is very beneficial to certain populations around the world, and combined, we can sort of improve not only our health, but also the comfort of people in the regions that are hot and arid. In terms of market, our first market that we launched in was Australia that we've been operating from. And if we just look at the commercial roof market alone, and if we were to target 5% of that, we would be earning about 150 million. And that is just the roof market. So if we were adding in our introduction of water harvesting capability and expanding into other industry verticals and international markets, that sort of grows, because we've only ever sort of worked so far in Australia and New Zealand, and we plan to go overseas. So I guess we've come to this point where, through spinning out and having raised funding as well as non-dilutive grants, we've come to a point where we are prototype ready, and we have secured a couple of pilots that are in agreement at the moment to be able to apply our paint and collect data over time and see how it works. And obviously, through the last few weeks and months of working with EnergyLab, we've also been able to, I guess, refine our model and commercialization model to then be able to take it overseas. So the next plan beyond this is to go full throttle in terms of our commercialization. So next year we will be in Malaysia and Singapore, where we hope to service the demand for our product suite that's coming out of that region, and also expand to other applications such as agricultural cow sheds, for example, old mining towns that have requested our service, and also solar panel installation. We have the right team to take it, from our founders having spent 10 years in this space to now our commercial heavyweights from our board to the core team. So hopefully it will be an exciting next year for us. And just thank you for your time for listening, and happy to answer any questions.
Bill, thank you so much for that presentation. And thank you to everyone who's been posting questions. We've got a lot of questions coming through already, which is wonderful. So Dill, a question's come through from Sam Ringwald from Connery Tech. What testing have you done for UV stability effectiveness over time? And what lifespan do you anticipate the product has?
So we have done our own testing on the roof of the University of Sydney over 12 months, and that has shown us that it is robust and effective, and that's where we've got our data for 12 months that we can then extrapolate. But in terms of lifespan, we do need to do further independent testing for that. It is currently going through some of that testing. We anticipate that to be on par, if not better, than what's already in the market. So 5 to 10 years, and if not more.
Brilliant. Thanks, Dill. Matt has asked, will you consider licensing deals with existing paint manufacturers and distributors?
Yes, so that's actually our number one model of entering a market, which we are currently working with paint companies in Australia to do a licensing deal exclusive for that market, for example. But we also work with the end user to then bring the leads back to them. And then we do have distributors in place as well for Australia, and at the moment in Singapore and Malaysia.
Brilliant. So that touches on a next question. David's asked, is US market entry near? So maybe if you can talk us through a little bit about what your sort of international expansion strategy is, or what sort of markets you're looking to next.
Yeah, so I guess we kind of put our hats and focus on the Southeast Asian market only because we got initial demand from there. And we, in talking to some of our network, especially through the EnergyLab, we've figured out that US is definitely on our pipeline, but not something that we'd want to do at the moment. Although we do have a couple of leads that have come out of there, but it's going to be a little bit tough, and we kind of have to wait and see how we're doing in terms of the geopolitical scene and economics of the US market.
Bill, thank you so much. That's all we have time for today. We've had a few more questions come in the chat box, so please stick around to answer those. Thanks, Dill. Brilliant. So next up, we have Sahand joining us from OptiGrid. Sahand, please go ahead and share a bit about OptiGrid with us.
Thanks, Meryl. Hi everyone, I'm Sahan, CEO and co-founder of OptiGrid, and today I'm going to first give you an overview of OptiGrid, what we've been doing over the past few years, and basically go through our first product very quickly. So just to give you a bit more context on what problem we're trying to address, over the past few years, we've installed a large amount of renewables on both supply and demand sides of the power grid. And because the generation from these renewables depends on the weather, it's volatile and unpredictable to some extent. And this makes the balance between supply and demand more volatile compared to 10 years ago. And as a result, wholesale electricity prices have become more unpredictable and volatile. This figure shows the wholesale electricity prices in South Australia about 7 years ago. As you can see, there's a peak in the morning when people wake up, turn on the kettle, demand goes high, and one in the afternoon. There are some peaks and troughs, but overall the pattern is predictable. And this is electricity prices in South Australia on the same day this year. As you can see, it's become much more volatile and unpredictable. And the problem is that generation assets, and importantly, grid scale batteries, need to respond to these prices. Batteries need to sell to the grid when the price is high and buy when the price is low. And this unpredictability makes it harder for them to achieve that. And from another viewpoint, South Australia is in a way a window to the future of electricity markets because it has one of the highest renewable penetration across the world, and many other grids are going towards the same level of penetration over the next few years. As a result of this unpredictability in the electricity prices, batteries are missing a significant amount of revenue in the energy market. This figure shows the difference between the actual and potential revenue of two grid-scale batteries in national electricity market in Australia. The first one is Queanbeyan battery in New South Wales. The bottom one is Lake Bonny battery in South Australia. And the figure shows the actual and potential revenue in the first 6 months of 2023. And potential revenue is the revenue that they could have made if they had perfect foresight of the future. So what we're trying to do is to basically address this issue to the extent possible. Obviously, it's not possible to perfectly predict prices, but we think we can improve the current status of the battery performance. So what we are doing is developing software that maximizes revenue from batteries. The first piece is OptiForecaster, which uses different types of inputs, such as weather data, power system, and market data. We've developed a physics-informed machine learning model over the past few years at the University of Adelaide that predicts electricity prices for the next 24 hours, and that's done every 5 minutes. Using those predictions and information from the battery, information from the market, we use OptiVider to optimize the bids and operation of the battery in the electricity market in a way that it would maximize its revenue across all revenue streams. So in my PhD, I did a large amount of backtesting on the algorithms we developed over the past few years, and even we published the methodology that we backtest our algorithms in a peer-reviewed paper last year. And what we could see when we backtested our algorithm was that if our solution was used in real-world operation, we could have significantly improved the revenue of the batteries. So just to give you a bit more information about our journey so far. So we began this research about 4 years ago. We validated our models last year. We raised a seed round in July this year from IP Group, CEFC, UNSW, Uni Adelaide, and EnergyLab. We are now about 10 people or so. We've completed building OptiForecaster a few months ago, and now it's being used on real batteries to improve their revenue. We provide a product through an API to the customers, but just to give you, I guess, some idea of how basically the user interface works. This is basically the user interface of OptiForecaster. So here you can see basically the predictions done by our algorithm at each 5 minutes today. So you can see I'm going into the past, but obviously you can see the latest predictions at each point in time. And we also track the performance of the forecast and basically how we are doing over the past few weeks and different times. And again, another important aspect that maybe it's worth mentioning is that the electricity prices have become so volatile that it's no longer possible to predict them accurately with a point, and using probabilistic forecast is actually one of the key areas that we are using to improve the revenue of the batteries using OptiBidder. But if you're interested to learn more about us, definitely feel free to reach out, and happy to answer any questions.
Brilliant. Thank you so much, Sahand. Great to see the platform live in action. So Sahand, I'd love to know, you mentioned that OptiForecaster is being used on real batteries currently. How's that going so far? Have you had any learnings? Yeah, would love to hear a bit more about that.
Sure, yeah. So it's being used on behind the meter batteries. I guess one learning is that I guess the value to the behind the meter battery is quite different to the front of the meter batteries, but we can still see that better forecast can help improve the performance of the batteries regardless of whether they're located in behind the meter or front of the meter. The focus of OptiGrid itself is on building a battery operation and trading platform for front of the meter, but we think OptiForecaster can help behind the meter batteries as well.
Brilliant. Thank you. And so it would also be really interesting to know who's your sort of ideal customer? Like who operates these batteries that we're talking about?
Sure, yeah. So basically anyone that owns or operates battery can be our customer. The ideal customer is someone that has developed and owns a front of the meter battery. It can be a sub 5 megawatt battery, 1, 2, 3, 4, 5 megawatt battery, or a scheduled big battery that operates in the market. And there are international renewable and battery developers that are coming, actually many of them, to Australia over the past couple of years and developing utility scale batteries. They're our ideal customers.
Fantastic, thanks. And Sahand, a question's coming from Yun. Yun's asked, is OptiForecaster controlling the battery automatically or just informing the operator?
Great question. So OptiForecaster does the electricity price prediction and provides the information for the decision-making tool to operate the battery. But we have another product, OptiBidder, which directly controls the battery. So OptiForecaster forecast is an input to the OptiBidder, which directly controls the battery and sends the set points to the battery and bids to the market.
Brilliant. Sahand, we've got quite a few questions coming in now. We've just got time for one more. So John has asked, can other applications access OptiGrid Forecaster through an API?
Yeah, definitely. Yeah. I guess the important question for me is whether this can help. So what we usually do, and we've done it with a couple of other clients, is that we discuss the application. We try to analyze how this can potentially help them. And if we see the value, then yes, definitely.
Brilliant. Sahand, that's all we have time for today. Thank you so much. And I invite you to stick around and answer some of the questions in the chat box. Thanks again.
Thank you. Cheers.
Brilliant. And just a reminder to everyone, such great questions coming through. If you want to connect with any of the founders, please feel free to reach out on LinkedIn to myself or the founders directly as well. I'm sure they'll be happy to continue any conversations. So next up, we have Eccentric. Roosbeh is joining us today to share a bit about the business. Hi, Roosbeh. Please share a bit about Eccentric with us.
Yeah, sure. I'm on hotel Wi-Fi at the moment, so hopefully it's not choppy. But let me go ahead and share my screen. Are you able to see that okay?
Yes, it's not in full screen. It's not in full screen, but we can see it.
Okay, I'll just do it this way. So I'm Roosbeh, I'm with Eccentric, and we are developing soil measurement tech. And one of our big value props is that we're capturing soil carbon information rapidly, accurately, which can help inform emerging agricultural carbon markets and add transparency and accountability. But in addition to that, and in parallel, we're capturing other data that we can use to inform efficient agriculture and increase sustainability of operations. So soils possess an estimated 2 to 5 gigaton carbon abatement potential, but there's much more to soil than just the carbon itself. There's also critical macronutrients which affect plant growth in different ways and plant nutrition. And so that's the kind of data that we're capturing, which enables management practices like precision agriculture that have been shown to decrease lime use by up to 40%, fertilizer use by 20%, and also increase yields by up to 15%. So these are significant gains for the bottom line and also for the environment as well. The problem with traditional methods of soil carbon quantification and really just any kind of traditional laboratory measurement is that you have to obtain your field sample, you ship it to a lab where it's processed and analyzed using these big bulky machines. These things are expensive and it can take weeks to get your results back. And then in addition to that, depending on which analytes you're looking at in the soils, you'll probably be using a different big bulky machine, which adds to the cost and the turnaround times. So incredibly inefficient. And that's the problem that we're solving with our patented multi-sensor approach to soil measurement. It is rapid, it is low cost, it is a portable device, and we're getting excellent results. So we have our prototype pictured here on the side. Previous to this, we built our instrument as an attachment for existing portable X-ray fluorescence instrumentation. I won't get into what that is because I don't think we have enough time for that. But suffice it to say that we didn't want to rely on other manufacturers. And so we're building a world first portable X-ray fluorescence device that natively incorporates our proprietary sensors. And we have 3 active patents on this with additional patents pending as well. So as a soil scientist, I can tell you that there's tremendous overhead with sending people out into the field. And if you're going through the trouble of having someone go out to capture information, you're incurring that cost right away just by making that decision. And so while you're out there, you should capture as much information as possible. With carbon crediting methodologies, you're analyzing soils maybe once every 5 years. And so there's a big gap of information between which you don't really know what's going on and how your new management practices are affecting the soils. Whereas the kinds of agronomists that we're working with are going out to measure soils once a year. And so for us, the carbon information is kind of like a byproduct of these other things that people are doing, but they're not doing a good job because it's prohibitively expensive. And so our instrumentation is providing unparalleled data yields. We're getting the carbon information in addition to that other critical macronutrient data, which can be used to help address soil constraints, which affect yields. So the soil testing market is expected to hit about 11 billion by the year 2030. We are not targeting the farmers themselves. We are instead targeting agronomists, carbon markets, and corporates that are interested in increasing sustainability of their operations. Corporates like PepsiCo, with whom we're conducting pilots right now in New South Wales on potato farms. And so we're starting with soils, but we can also see our technology being applied in food, plant, mining applications where we're having fruitful conversations right now. And that is without any change in the actual hardware itself. So we're able to apply it in many different areas, which gives us an edge. So myself, I'm Rusbe, I'm co-founder of Eccentric, PhD soil science, master's geology, bachelor's in earth science. My co-founder, Chung Hyun, has a background in design and engineering, and she's worked at places like GM and Magna. And we also have world-class advisors surrounding us. And so, yeah, happy to jump into questions. I think that might have been a little over, but I'll stop the share now, and then we can get into Q&A.
Thanks so much, Rusbe. That was perfectly on time. So would love to hear a bit more about how the PepsiCo trials are going, and also just talk us through the product itself. So is it built? What sort of stage is that at? Are they actually out there on the field being used right now? Yeah, would love to hear about the product.
Yeah, it's a work in progress. So we originally built it as an attachment for existing portable X-ray fluorescence. Portable X-ray fluorescence looks like a gun. You basically point and shoot your samples with X-rays, and you're able to detect signals, and you're able to capture a lot of information. But you don't get that critical carbon information. And so, given our resource limitations, we had to build it as an attachment, which makes life really difficult for us. We have to play by other manufacturers' rules, form factors, and ways that they allow you to export data. And so the version that you saw in the picture, that's the way it stands right now. It's an iterative process. So we keep going back to the partners that we're working with for feedback, and iterating on that design based on feedback. So just concrete example, we're using a touch screen, and originally I thought that this was going to be great. Like who doesn't like using a touch screen? But people are using this with dirty hands, and sometimes they have really big fingers and not exactly the required dexterity to operate it. And so that made us realize, well, okay, maybe we should implement analog buttons. But at the same time, that's much more difficult than moving lines of code. So during our iteration phase, we're using the touchscreen, and then later, when the design is more finalized, we will convert to analog buttons. So it's a work in progress.
Absolutely. And just to mention as well, Rizba actually shared with the team a few months ago during the program, he was testing what color he should make the machine, and we even got to vote on that. So we were all really happy to contribute a little bit towards the device as well. So just one more question, Rizba. You mentioned the global market opportunity for soil measurement is rapidly growing. What sort of markets are you targeting globally?
Yeah, I think Southeast Asia, Australia, obviously, this is where we're based, and this is where we do everything. Southeast Asia, we've received a lot of inbound interest, and so we're definitely exploring Southeast Asia. US, Germany, those are other areas that we're looking at currently.
Fantastic. Lots of opportunity. Rizba, thank you so much for joining us today, and stick around. I think there are a couple of questions in the chat box for you. Really appreciate you joining us today. Thank you.
Thank you very much, Beryl.
All right. Next up, we have Bob Kreiner joining us from Stralis.
Hi,
Looks
Beryl.
like he's
Hi, everybody.
in the hangar with us today. Hi, Bob.
Yeah, coming to you live from Brisbane, here in our hangar at Brisbane Airport. Yeah, do you want me to kick off, Beryl?
Go for it.
All right. All right. Hi, everybody. Yeah, my name is Bob. I'm the co-founder and CEO of Stralis Aircraft. Here at Stralis, we make emission-free hydrogen electric aircraft and propulsion systems. And today I'm going to do a little bit of a different pitch. I really want to give you a quick background on our company, what we're building. And then I want to show a bit of a video of some of the work that we've been doing here, some live testing. And then I'm actually going to go walk around and show you some hardware in the background. So yeah, see how it goes. Yeah, so just quick background, the problem that we're solving, I think we all know transport is moving to decarbonize. Aviation is a very stubborn problem. It's one of the hardest to decarbonize, but the industry is committed to net zero by 2050. My co-founder Stuart and I, our background is actually working on battery electric aircraft. So the two aircraft you can see there, we developed and flew in 2019 and 2020. And we basically realized the drawbacks that exist with battery technology. You simply can't fly far enough. Another alternative sustainable aviation fuel has drawbacks. It has challenges around scale. It's quite expensive. And so we actually believe that hydrogen electric propulsion will be one of the key pieces that helps to decarbonize commercial aviation. Just to explain what hydrogen electric propulsion is. So there's three key components in our system. We have a liquid hydrogen tank, which we store the wing at the tip of the wings. That hydrogen passes to a fuel cell, which converts hydrogen into electricity, and that electricity is used to power an electric motor to turn the propeller. So we're not burning the fuel. The only byproduct from this is heat and water vapor. And we're actually testing these systems now. And it's funny, I've been working on this problem for a couple of years now, and actually witnessing and seeing us use hydrogen running through this system and see the only thing come out of the tailpipe being water vapor. It's really, it's almost like magic. It's pretty exciting stuff. So I want to explain a little bit about why hydrogen is good for aircraft. This is a payload range diagram. So on the y-axis is how much you can carry on board the aircraft, and on the x-axis is how far you can fly. This curve is for the conventional fossil fuel powered aircraft. So you can carry 375 kilograms of payload. If you try to fly the full range, you actually have to reduce the amount of people that you carry on board to fly the full distance. If you try to do a battery retrofit of the Bonanza aircraft, you end up with a significantly reduced payload and you really can't fly very far enough. So it's not very useful. If you try to use current fuel cells that are available today in cars and trucks, you can fly longer distances, but you can't carry useful payloads. At Stralis, we've invented a new type of fuel cell that's 6 times lighter than the current state of the art, which unlocks this kind of 10x range extension on battery electric with twice the payload. And if you compare it to fossil fuels, we can actually fly twice as far with a substantial payload of 300 kilograms. So this is fundamentally, hydrogen is ideal. It's a lightweight fuel, but it needs this fuel cell breakthrough to unlock its capability. And so this is where there's actually been a breakthrough in fuel cell chemistry. It's called ion pair, and we liken it to what the lithium-ion battery did for electric cars. As you're probably aware, 15 years ago, the lithium-ion battery became a thing, and it unlocked all of these electric cars companies that could go out and make cars that can drive useful distances. Something similar just happened in the fuel cell space, and we're the first to patent and design a fuel cell system around this new ion pair technology. And again, it's 6 times lighter, unlocking those long distance ranges that you're talking about. So this is our roadmap. We start with our Bonanza aircraft, and the 2 aircraft you can see behind me, I'll introduce in a second. It's a 6-seat airplane that we're planning to fly next year. We're then planning to scale up that technology to a 15-seat aircraft that enters service in around later this decade. And then we'll scale up to a 50-seat aircraft beyond that. Yeah, so we've colloquially named our aircraft Bonnie and Clyde. Bonnie named after the Bonanza. That's the one here on my right, and that's the one that will fly sort of Q3 next year. Clyde is our ground test aircraft that we use for extensive testing on the ground, basically. And again, next year, we're planning in Q3 to achieve Australia's first hydrogen electric powered first flight here at Brisbane Airport. So this will be a huge moment for Australian aviation. Okay, I'm going to quickly switch over to a video. This actually works okay. I think it's better to show you what we're doing, and I'll just kind of narrate over it. So this is our fuel cell part that we're using to currently power Clyde. Clyde has an electric motor in the engine bay, and this is out on the hard stand. So we're at Brisbane International Airport, and we have a hangar, and we have a space outside where we do testing. And this was a spin that we did 2 weeks ago, which was the first time hydrogen's been used to power a propulsion system at an international airport in Australia. So yeah, huge, exciting moment for the team. Thank you, Beryl. We're not flying yet, but these are really amazing moments, and I think we have to celebrate these little wins and really bring people on for the journey. I think some people are scared of hydrogen. It's new, it's unknown. And we really want to tell our story and show people that we can handle this stuff. We can use it. It is real. It is available, basically. Yeah. So I think that's basically all I wanted to show down. I'm going to quickly stop sharing. And real fast, Beryl, how are we for time? Do we have a quick second?
We're just on time, but I think we'd really all love to see.
Super. I know this is, I hope I don't make people car sick, but I just want to show you. So this is inside Clyde's engine bay. That is a 200 kilowatt electric motor that weighs 20 kilograms, and it replaces a 200 kilogram piston engine. And then this is our fuel cell cart here. So that's basically the fuel cell where the magic happens. This is hydrogen system. Basically blue is cooling, black is air, and red is hydrogen. So yeah, anyway, come visit us if you're ever in Brisbane. We're doing some exciting things, and happy to take any questions. Sorry if that was fast, but pack it in.
Brilliant. Bob, thank you so much. Amazing to see all the nuts and bolts of it. We've got some great technical questions coming through.
Fire away.
Lots of questions. We only have time for 1 or 2, I think. So I'll start. Sure. Tilney asked, does using only the wingtip tanks change the wing load profile of the wings and therefore the fatigue profile of the wing?
Great question. Short answer.
Or do you account for that?
Yeah, sorry. Short answer is no. And interestingly, the Bonanza is actually designed to have wingtip tanks for range extension. So the aircraft is already sized, and our wingtips weigh literally exactly what the original wingtip way. So we are doing that analysis and checking it. So it's a very valid question, but we chose the Bonanza because it already had wingtips included in the design.
Brilliant. And Dean has asked, what are the other potential use cases for your fuel cell?
It's a great one. Yeah, so the unique aspect of our fuel cells is that they're lightweight, but they're also low drag, and they can operate in quite harsh environments, so higher temperatures. So we're actually looking at mining trucks as one potential application where they operate in like 50 degrees C mines. There's also drones, so long-range drones that we're looking at. And there could also be long-range, like heavy-duty trucking. That's another application where batteries don't work. Hydrogen electric would come in.
Brilliant. So quite a few use cases there.
We're also trying to stay focused. I mean, our core is aerospace, but definitely potential to license the technology and get revenue from other streams.
Absolutely. And I think we're all very excited to see a flight next year, hopefully.
Yeah, it's going to be a moment.
So absolutely. So one more question from Ewan. What's the ion pair fuel cell operating temperature?
Yeah, great question. And that's actually the secret that unlocks this. So it operates at 180 degrees Celsius. Normal fuel cells run at 80 degrees Celsius. And the key difference when you go to higher temperatures, you actually can reduce the size of your cooling system because you have a higher delta temperature between the air you're trying to reject the heat into. And so effectively, that's one of the key ingredients that gives us this lightweight advantage.
Fantastic, Bob. And I'm just going to ask one more question because it's a brilliant one.
Yeah, it is.
Ani has asked, what is your big vision for Stralis, Bob? I.e. the craziest and the most ambitious one?
I love this question. I kept this out because it freaks people out. No, I think Australia should make aircraft. I think you look in like Canada, Brazil, America, Europe, there's no reason we used to, we don't anymore. And I really think that this transition to like an emission-free future in aviation, it opens a gap like what Tesla's done in the car industry. We actually in the future want to make aircraft at scale here in Australia and export them to the world. And people think we're insane for thinking that, but people thought Tesla was crazy. We'll get it.
Someone's got to do it, Bob, and we back you all the way. Thank you so
you.
much for joining us today, Bob.
Awesome. Thanks, everyone. Appreciate it. It was fun.
Brilliant. So next up, we have Guido and Renate joining us from Brownie.
Hello. Hello, everybody. Have all those fabulous innovations made you hungry yet? Well, then it's time for a brownie, I guess. A solution that helps 54% of GDP to transition to a more sustainable economy. Can I introduce you to Sam? He runs a small business manufacturing logistics, and he's been doing so successfully for 13 years. But Sam's struggling. Cost of business are going up, energy costs have exploded, red tape is only growing, and it's just ever more demanding. Sam's not alone. Small business confidence in Australia is at its lowest ever, and small businesses are losing market share to large corporations. Well-intentioned, but sustainability only makes that worse. Sam's now being asked all sorts of different things by customers, banks, investors, even by his staff. No tender where that's not being requested, no supply agreement or loan application that doesn't ask for it. Sustainability is no longer optional, not even for the smallest business. And while a big business can cope, spend $10,000 to hire experts or engage consultants, Sam obviously can't. He doesn't even know where to begin, and he can't continue to do this because he's already giving up on even trying for tenders. So like 280 million other businesses, Sam's really struggling to stay afloat. My name is Guido, and I'm one of the founders of Brownie, and I've been in Sam's shoes for the last 20 years. I've run businesses small and large, and I found out a surprising thing. If you actually embrace sustainability, it'll make you grow faster, increase your profits, and make more money while you better manage your risks. And once you know how, it's not even hard. I'm proud to work with these incredible co-founders to make that experience available for all Sams out there. Kate Bennett, a sustainability and framework expert with 20 years of experience in the space, Dr. Jill, our CTO and CPO, an astrophysicist with decades of experience in AI, big data models, and algorithms, and obviously with Renate, who's here with me. Over to you, Renate.
Hi, everyone. I'm Renate. I'm an environmental engineer that has about a decade of experience in sustainability consulting, and I look after the sustainability side and the partnerships and business development piece of Brownie. And together, we have the support from world-class advisors, universities, and accelerator programs such as EnergyLab, and we are trying our best to solve Sam's problem. So Brownie has made sustainability simple, practical, profitable, and delicious. With Brownie, all of the SAMs around the world can solve sustainability about 90% cheaper and faster than with traditional consulting services. And most importantly, they can actually unlock opportunities for increased growth, increased margins, and secure funding. Brownie is an end-to-end, I'm talking faster than you can actually push the buttons, Guido. It's not surprising. Brownie is an end-to-end sustainability action and management solution. It is built specifically for small to medium businesses. You won't ever excite a small to medium business about reporting. The key to get them excited is to talk about action, and this action can actually unlock their success. And this flywheel actually shows it in a simple 5-step process. So the next slide, Guido, is step 1, discovery. Our customers answer a few questions in about 4 minutes. No need to look up any data, and we can actually start to get the ball rolling. Step 2 is focus. Within minutes, they can actually understand what areas across environmental, social, and governance are the most important and impactful to their business, and they can actually choose where to focus and where to get started. Step 3 is action. Straight away, they're presented with recommendations that you can see here on the screen on how they can improve their business and their chosen focus area. Each action, as again you can see, is ranked for its impact on environmental, social, and governance, as well as the impact on the business's financial position, explicitly linking sustainability action to business success. Step 4, step 3, a little bit more details here. They can actually dig into, sorry, Guido, my bad. They can actually dig a little deeper into that specific action and learn more about it to make an educated and informed decision right away if this is the right action for them. We then connect them to the tool via Brownie, to the resource or the partner that can help them achieve this goal. Step 4 is the progress. By completing their actions, they get Brownie points, because who doesn't like to accumulate Brownie points? Within hours, they can score themselves, and they can actually upload data to validate their status and provide evidence of their own actions. They can then track and benchmark, and if they like, they can actually share this screen, their progress, with internal and external stakeholders through this always up-to-date sustainability dashboard. And they can actually use this progress to win tenders, attract customers and investors, and just keep their staff informed. And super exciting, coming in 2025, they'll actually be able to pick real-life business targets they want to go after, like you can see here on the screen. And they can actually help them right on the platform. Brownie will guide them to meet these goals, will translate the requirements of whatever business goal they choose. We'll map them to actions on the Brownie platform, and will guide the SME effortlessly to meet these requirements and win that tender, secure that loan, or become part of that larger supply chain. Pretty exciting. Guido?
So you've seen that Brownie is real simple to use, but it's built on solid frameworks, it's science and our expertise, and it uses AI and algorithms that we've developed ourselves to use the data from all the members of the universe in Brownie to make recommendations to the particular business looking. We call that engine Hippie, our holistic, integrated, proprietary performance improvement engine. Hippie has helped us, together with the EnergyLab Accelerator, obviously, to go into some real growth mode. We've doubled the number of companies over the last 6 months that have subscribed, and we've got 250 of them now. We had over 60 of those in paid subscription, and so far we haven't lost a single paying customer yet. Rather, our customers give us raving reviews and refer us because they can see how a simple tool can make them more successful while making them more sustainable. We go to market through partners, and that is an extremely efficient way. We give them tools, we give them content, we give them training to their trainers, and they then go out and with their trusted access to small businesses, present Brownie to the market. This could be industry associations or corporations like Dexus, where we help them engage with their tenants to get on the journey. This is only the beginning. And if you know partners who would benefit, we'd love an intro, and we might even bring a Brownie. Thank you.
Brilliant. Thank you so much, Guido and Renate. Definitely making me hungry. I would love to know, why did you call yourselves Brownie?
Well, because everybody loves brownies, right? We've done studies, it's 97%. And it puts you in a positive mood, as it should, because it's good for you. And so is sustainability. But when people hear sustainability, they hear reporting. And when they think reporting, they're doing it wrong. So we have to break that shell.
Absolutely. And I think a real sort of perceived challenge around ESG reporting and sustainability is the kind of cost of it all, right? But you say you're 90% cheaper and faster than traditional solutions. So can you talk us through that a bit more? How much faster are you? How much more affordable?
Yeah, I've seen a post this week where the average cost of a sustainability report is 240,000 Australian dollars. Now, for smaller business, that's probably not the right number, but you're still looking at spending months, if not a year, and spending $50,000 to $60,000 easily. And that's only to show the world how bad you are. Then you haven't done anything to improve. With Brownie, you can get to that point within days, and you will expense maybe a few $100s. But more importantly, you'll be able to win them back and make more money than you've actually invested into the platform. So it's a positive ROI very quickly.
Brilliant. Sounds like a no-brainer. So one more question. Heidi from the audience has asked, what have you got planned for the next chapter, sort of tech-wise and overall, what does the next sort of year look like?
Yes, so technically, Renate has already given a sneak preview. We're going to tie this business goal directly into the platform and make it even more pragmatic and practical to use sustainability for your advantage. We're already getting a lot of, as I also said, there's quite some big names in the pipeline for being partners to distribute Brownie. So now what we're also getting is actually interest from countries abroad. So we have a good network already into Asian markets, but also Europe, which is very advanced in this space, and even the US, because in the end, it's not about ESG, it's about listening to your stakeholder and making your business more successful. And that's a very unpolitical proposition.
Absolutely. Thank you so much, Renate and Guido, for joining us today. And please stick around for any questions in the chat box.
Thank you.
Come see us for Brownies. Bye-bye.
Bye.
Bye. So next up, we have Ringo Thomas joining us from CLT Toolbox. Ringo, the stage is yours.
Thank you very much, and amazing presentations, everybody. So please let me know once my screen is actually sharing.
Or it's just loading. Yeah, looks great. Go for it, Ringo.
Brilliant. Well, hello, everybody. I'm Ringo. I'm one of the co-founders of CLT Toolbox, and we're building the platform for sustainable building materials. So there are two mega trends in construction. One of them is around the decarbonisation of buildings. It's both materials and the operational mechanisms used. The other one is around productivity. So there continues to be opportunities to be more efficient in the way that we build buildings. What are we doing about this? Our mission is to bring sustainable building materials into the mainstream. So the place that we start is concrete's new competitor, timber. You may have seen some really beautiful timber buildings around Australia already and around the world, and they have a number of benefits. One of them is decarbonisation. So building materials do contribute to 11% of the greenhouse gas emissions. And when you plant a tree, it's like putting a sponge into the soil that sucks carbon out of the atmosphere. The productivity, there are some buildings that you can put up using mass timber specifically, where you're able to put up multiple stories per week as opposed to multiple weeks per story. And this is due to concrete needing to dry and things like that. And biophilia is a broad ranging category, but one of the things is being around natural materials tends to enhance occupant health and improves rental yields. So there's a number of reasons why engineering firms, architects, developers are all wanting to use it. So the problem is that timber, it's not easy. So it's an entirely new material. We did a white paper. There's hundreds of hours of unpaid hours building infrastructure, making mistakes, and there's a big pile of burning cash for any engineering firms that decides that they want to listen to all of the reasons why you should be using sustainable materials. And the challenge here is that without education, without design infrastructure, engineers are fighting an uphill battle. It's a long and costly journey, and we don't live in a world where you can, being nice and doing the right thing doesn't necessarily have a premium. So this is where we come in. We're trying to build a platform to make this easy, and we're trying to use network effects for this. So we have built automated design routines and education around using mass timber. We have engineering firms who save time in building that infrastructure using our platform. And then we have the product suppliers who exist in the timber industry who have their products on our platform. And this is what it looks like. So these are individual elements that you would be designing with on the CLT Toolbox platform. So it's things like floors and walls and beams and columns and screws and a whole bunch of really complicated things that engineers need to sign off on. So we've actually got pretty strong traction so far, both on our customers and our supplier side of the platform. In only around 12 months, we've had over 2,500 user signups. We have over 250 monthly users. This is only in the engineers side. We have over 40 paying customers across Australia, New Zealand, and Europe, 150 pro users. On the supplier side, we have over 20 paying customers, 5 different product types, and there's product availability in over 20 countries already. And this is only 12 months in. And the reason why I highlight this is because we use our network effects for our global go-to-market playbook. So, all the way over here, we're in our second year agreements in Australia and New Zealand, selling our structural software. But, right now for the USA, Canada, we're doing some basic market interviews, but all of them follow the same pathway to market, using both the suppliers and the engineers to launch and gather traction and build those network effects and our moat. For example, in Europe this year, we've had over 1,000 new user signups in our beta program. We've had over 400 meetings. We've had 50 participating companies in our beta program, and this is all before we've even released the software to the market. So you can imagine that by the time we get there, we get a lot of positive feedback. Now, how does this play in? So there are 2 horizons. One is about building the platform for the sustainable building materials. And so that's not just timber, that's structured. It's across different professions and across different product types. And then over time, how do we become a multi-billion-dollar company? It's by creating an alternative path to design and getting on that sort of digitization trend as well as the decarbonisation. Who is it that's doing this? We are a 40-person team already. We have co-founders, myself and Adam in Australia. Adam is a structural engineer. He knows timber. He's also worked on the supplier side. He's also been voted as one of the most innovative leaders in Australia. I myself, in a previous company, I built over $50 million in revenue as a head of sales in 4.5 years in a software engineering firm. And in Indonesia and Ethiopia, we have our leaders running our offices over there. I'm sure I'm about to come up to time. I just spoke about this, but this is the 4 of us who are the co-founders. They're all legends, and our infrastructure factory, this is what we do. So we basically build really complex spreadsheets with our teams. You can hear my 5-minute timer going off. We then hand them on to our software teams. We then pass them on into the market and deploy them. And our goal is to use software to bring sustainable building materials into the mainstream by providing infrastructure that engineers are able to use to successfully do so. So I will stop there. I don't know how to stop sharing. There you go. Perfect. So thank you very much.
Thanks so much, Ringo. That was brilliant, and just incredible to see how much growth and traction you've achieved in just 12 months. Really, really incredible. So I'd love to know what's going to unlock growth for CLT Toolbox in the next year.
Yeah, well, so we basically the majority of our revenue and traction has come from the Australian and the New Zealand market so far. So we've been preparing for our European launch for around 12 months and just getting the team and the strategy right. We're launching in January. We'll start to monetize there, and then we'll be doing the same launch following the same model in the USA and Canada starting around March, April. And so I think, what unlocks growth for us, we will be doing another capital raise next year. Extra money does help, but also we do have a lot of revenue coming in. So, we do believe that we want to be sustainable, ironically, in our growth as well.
Absolutely. And it's brilliant to see success you've had in so many different markets already. And I guess testament to the fact that this is a really a solution, a kind of unique solution, right? There aren't many other players out there. So that's absolutely brilliant. We've got a question that's come through from Tilney. They've asked, are you integrating this with IFC and open source digital data and models?
Thanks, Tony. So as the non-engineer in the team, I may not be able to answer the IFC part, but I think in general, our goal is to integrate with some of the major software platforms, and that's the feedback that we get from the engineering firm customers. So, the first version of it is just going to be simple export and import data so that people can, if they have their building design in a different system, they can then do the individual element analysis or design through our platform. So over time, we will integrate, but right now, because we're focusing not just on concept design, but detailed design, it's all about the core calculation. So that's the problem that we're solving, because right now people were solving that problem with spreadsheets, and it's creating wastage on projects and stopping mass timber projects going ahead.
Fantastic. Ringo, thank you so much for joining us today. That's all we had time for. Really appreciated the demo, and stick around for any questions in the chat box. Thanks, Ringo.
Thanks, everyone.
Brilliant. So next up, we have Infigo Labs. Prashant is joining us today to tell us a bit about the business. Go for it, Prashant, when you're ready.
Yep. So can everyone see my screen?
Looks great.
Great, thank you. So Infigo Labs, essentially we have developed a technology that is a novel way of making steam. So for centuries, industry has been making steam by boiling water in metallic tubes and suspending these tubes in furnaces. And instead, we have a technology that drastically slows down the explosive reaction between hydrogen and oxygen to produce very high temperature steam, which otherwise would not have been produced using the traditional methods. What that does is that unlocks value in certain sectors, and we are focusing on sectors where there's a compelling case to proceed. So this is where we come in as decarbonizing ethylene production is where we are focused on at this time, and through steam cracking with zero emissions. So we're primarily focused on increasing yield and coke-free operation, and zero emissions happens to be the side benefit. So those who are not familiar, ethylene is the largest volume molecule humans make, even more than fertilizer. And it's pretty much used in everything from engine coolants to clothes and even solar panels. The silicon cells are coated on both sides by a thin film of ethylene vinyl acetate. So it's a product that is going to see significant growth and has seen in the last 10 years as well. So the current process actually makes ethylene by cracking the hydrocarbon in metallic tubes while suspending these tubes in furnaces. So there are multiple burners that provide the intense heat, and these tubes essentially contain the hydrocarbon inside, which is being cracked in the presence of some steam. The challenge here is the metal actually introduces temperature limits, which limits the yield that can be achieved. The theoretical yield cannot be achieved because of the metallurgical constraints. The second thing is that the metal, the nickel and iron in the metal actually creates an undesirable catalysis and quickly builds coke, which hinders the heat transfer from the burners into the hydrocarbon. And Infigo Labs technology is addressing these core issues. So we eliminate the burners and we are eliminating the coke. And that has been a significant game changer in the production of this large volume molecule that we make. So currently the industry has to take 20 to 60-day decoking interruptions depending on the feedstock that they're using. And we therefore eliminate those interruptions as well. So how do we do that? I would like you to focus on the center here. So essentially what we are doing is we are imparting the entire heat of the reaction through a fluid to fluid heat transfer from a very high temperature stream of steam that, as we said, we create in a ceramic line reactor, unconstrained by metallurgy. And then we are mixing that with the hydrocarbon to achieve the cracking. And because we don't have a solid surface through which we transfer the heat, there is no coke formation, and any coke, any small amount of coke that's formed is actually destroyed by the steam through a particular chemical reaction. So here we are enabling a breakthrough where we are giving them complete coke-free operation while giving them the high temperatures they need, unconstrained by metallurgy, giving them a step increase in yield. And therefore, decarbonizing here, in this case, becomes like a side benefit. And because we are producing more hydrogen through that process, we actually bring it back for a reaction, and we use that back in our reactors. It's a bit complex, but that's the easiest way I can explain it. So at the core of our technology we are, as I said, we are drastically slowing down the explosive reaction between hydrogen and oxygen in a ceramic lined reactor. And whilst our base case is using electrolysis in future when green hydrogen becomes economic, but arguably we can use any source. And currently Dow, which is one of the customers we have been talking to, has taken investment decision in using blue hydrogen. So we can pretty much use any source of hydrogen and thereby become energy transition friendly. So these are some of the yield increases that we have, which is step increase in ethylene yield, as well as nearly seven times the acetylene, which is a high value industrial product. And as I mentioned, we produce twice the hydrogen for pyrolysis. So we are bringing a massive uplift to projects that FIDs have been taken in more recently, like with Dow, which is planning to combust blue hydrogen in furnaces without addressing the core problems. And this is where we bring a massive uplift to those kind of projects that are happening around the world. As I said, we've gained a lot of international traction. We've received a letter of support from one of the majors. We are progressing significantly with another ethylene producer who approached us, actually, interestingly. And then more recently, in fact, not listed here, is we are having 2 more meetings with 2 other majors out of Europe this month. This is my team. Myself, I'm a hydrogen combustion engineer. Christoph brings in massive scale-up experience from hydrocarbons as well as renewables. Derek is our commercialization lead, and Peter brings in, he has a CFA with a chemical engineering background. And I will stop there in the interest of time and take more questions. Thank you.
Brilliant. Prashant, thank you so much. I would love to kick off by just saying that Prashant is literally working with explosions. How cool is that? And Prashant, it'd be great to know, so, you know, you mentioned that right now a use case that you're focusing on is ethylene. Are there any other avenues that you are focusing on to commercialize, any other verticals that this can kind of be applied to?
So yes, it can be applied to several other verticals which require very high temperature heat and with the need to decarbonize, but we are focused on clear economic cases that do not rely on a carbon signal. And through some of the advice we've received, we are focusing on a smaller use case, which we're going to announce very soon, which has much wider applications. As a hint, we don't have a chimney stack, and that brings in, because all the heat after we impart to the process, it condenses into water. And so we do not have a chimney stack. And that combination of high temperature heat and not having any emissions to the atmosphere creates unique applications that we are working on at this time.
Brilliant. Okay, so it's applicable across some different sectors. Prashant, it'd be great to know a little bit more about the steam cracker itself as well. So this is obviously a kind of piece in a really big industrial machine, right? So what are some of the benefits of it? I understand that it can be retrofit to existing machinery. Is that right?
So yes, the way the industry operates is they've got multiple furnaces operating in parallel. So typical ethylene plant these days is 1.5 million tons per annum capacity. So being the largest volume molecule we use, these giants are adding capacity every couple of years in very big chunks. But each unit furnace is what we plan to replace as a retrofit. So because we run hotter, our residence times are shorter, and therefore we can retrofit into their existing space. So it's certainly retrofitable in a unit furnace, which is typically around 100,000 tons per year capacity. Yes, but we recognize that we need strategic partnerships here. We clearly have customer interest, but we are very careful as to, because we are disrupting existing business models, we are very careful as to what strategic partners we seek. So we are seeking for a win-win relationship. Our construction is different to the current cracker construction. So we are seeking partners that are enabled by this and enabling a new market for our partners, as well as they bring in all the manufacturing expertise to enable us to scale up while we provide the technology and license the technology. That's the kind of business model canvas we are operating to at this point in time.
Brilliant, Prashant. Thanks so much for sharing with us today. There are a couple of really great questions that have come through in the chat box, so please stick around to answer those. Some great technical ones. I'm sure you'll enjoy them. Prashant, thank you again. That was a brilliant presentation.
Thanks.
All right, and finally joining us today is Garth Payton from Gridstore Energy. Garth, please join us and take the stage to share a bit about Gridstore.
No worries. Thanks for the introduction, Beryl. And everyone, can you see my screen now?
We can.
Cool. Okay. Look, great to see everyone again, or at least virtually. And now, if I was doing this talk 5 months ago, I would have been saying to you that we were a battery storage company that optimizes the power output of solar panels. And in the last 6 months, that's changed quite a bit. And so I thought what I'd do is take you through a little bit about how that's changed for us. Now, you might remember this diagram from the Accelerator launch. And what we were showing here was how in a string of solar panels, when they're wired in series, we were using the batteries to save the overproduction of power that was greater than the lowest producing panel. Because in a string, you're limited by the lowest producing panel as to how much power you can get out. Now, what happened in the last 6 months is that we started some testing with the University of New South Wales. And as we were doing that, we proved up the results of what we were showing with the battery storage under the panels. And then we thought, okay, we're going to try the final part of that, which was if we had some demand for power at a particular time, we could use those batteries to inject power into the solar panels and bring everything up to the highest level it can so we can export more power at a time. And we got some really unexpected results. If I drop down to this, it's a summary of the table from the report from the University of New South Wales. So we were working with the Technology Translation Squad as part of the TRACE program. And we were testing, if you can see here, the shading on a panel. And then we were injecting power from our battery into the panel. And then we were seeing what the outcome was. And so you can see here the total amount of additional power that was being generated. In each of these cases, it was somewhere between 300% and 400% more power we were getting out of the panels than we were actually putting in, which was quite revelatory to us. And it turns out when we looked at this a bit deeper, the reason for it is when you have a shading incident, so like cloud cover, some dirt, panel misalignment, or manufacturing intolerances, it increases the resistance within the solar panel. So it makes it harder for the electrons to move around. So if you think about it like a water pipe that suddenly got a lot smaller, and we're trying to still fit the same volume of water through when it's really hard, so you get less overall. When we started injecting power in, we actually widened that pipe, so we reduced the resistance within the panel. And that made the entire panel work better, which is why we were getting that multiplier return on the power. So as a result, we've switched our focus now into what we call OptiCell, where we're looking to improve the performance of individual solar panels with a device that's about the size of a mobile phone. So it can be retrofitted to any existing panel. Going forward, we'd actually look to have it incorporated into the manufacture of the panel itself and used that way. But it introduces a couple of really significant advantages. On our testing to date, we're looking at somewhere between 15 and 30% more power on average across an entire day from solar panels. So on a retrofit, obviously that's giving you more power, greater income. Probably the biggest impact, though, is when we're looking at new installations. So there we're looking at somewhere between 19 and 34% reduction in CapEx spend. And it comes about because of two main drivers. The first is if you've got actually additional power that you can rely on coming from your solar panels. So in this case, take 15% that we could give you as a base. If you were building a 100 megawatt solar farm, you'd only need to install 87 megawatts of solar panels in order to do it, because you're getting 15% more power out of those to get you up to the 100. And bear in mind too that with the falling price of solar panels, they're only about 15% of the total CapEx. Now, that means you can save all of that additional money on land cost, site preparation, cabling, frameworks, everything. So there's a much bigger multiplier effect, if you like, on the CapEx side by having fewer solar panels. The other side that we improve is that we can knock another 6 to 8% off, because the way our system works, we don't need MPPT tracking in the inverter anymore. Our system does all of that better than an MPPT tracker, and we don't need a DC-DC converter. So we're taking about 6 to 8% of the capex out of there. And as a result of having constant voltage and no wasting of excess power as heat in low-producing solar panels, we increase the lifespan of solar panels by about 6 years, and we think inverters by about 3. And the constant voltage means that your solar farm isn't subject to FCAS style payments. So pretty big technical changes for us going forward. The other thing too is we're not using batteries when we're doing this. We're now moving on to supercapacitors, which is a really interesting field to be looking at. Been a lot of traction over the last 6 months as well. In the first column here, the first 3, we're really looking at technical traction. So we've, as I said, been working with the Technology Translation Squad at UNSW. We're actually just in the process of finalising another scope of work for some more testing with them at the moment. EDP, with whom we won the Energy Starter program earlier on in the year, they're taking our OptiCell technology and testing that at their Sun Lab in Portugal, probably early next year at this point. And CERIS, which is the Solar Energy Research Institute of Singapore, is incorporating OptiCell into some testing they're doing between solar panels and power optimizers to work out what's the best technology to present there. But probably the thing that we're most excited about, I guess, is 2 things really, is a partnership with Squadron Energy and Photon Energy that we put together. We've got an application jointly into AEMO. If you don't know Squadron, the private solar company, power company of Andrew Forrest. Photon's a $300 million listed European power company. So we're looking to do a 50 megawatt solar farm and a separate 50 megawatt solar farm as a control. So if anyone's got a 100 megawatt solar farm, I'd love to talk to you. But interestingly, probably in the initial go-to-market, we've had great success with Schletter, largest manufacturer of solar framing in the world. Big emphasis on rooftop solar, which if you think about what we can do now, rooftops, they're almost always constrained in terms of the total amount of power you can get out of them, or they're constrained by weight. And we can give you more power for fewer panels and less weight. So it's an ideal marriage there. And Koloska Solar is the Indian company we've been talking to. They're the largest installer of commercial solar in India. And they also manufacture their own panels and inverters. So it makes a really seamless integration of our technology into their ecosystem. And India is the fastest growing solar market in the world. So lots of things happening there. Canyon Solar, interesting crossover. They're doing solar car parks. Big client of theirs is Woolworths. And we've actually got one of the MDs of Woolworths as one of our shareholders. So that's proving to be a really fruitful interaction there. And Pilot Energy, who are based in WA, and they're building a 375 megawatt solar farm to power a green hydrogen plant. So lots of things going on. We've been focusing, as I said, because of the change in technology, largely on the technical side. And we're launching arrays probably in about February next year for our next stage of development. But yeah, over to you, Beryl, if there's any questions.
Absolutely, Garth, thank you so much. This is really some breakthrough stuff, and incredible to see that data coming through from your recent testing. So we've got a few questions in the chat box. One is from Bob. He has asked, does this replace microinverters?
Yes, it does. So microinverters will give you a result. I've actually got another diagram, actually. I'll quickly pull up for everyone. It's a technical explanation. So a little bit different from microinverters. They convert the DC power to AC, and I should preface this too, I'm a lawyer by trade, so my science may be a little bit off in some explanations, bear that in mind. But they convert the DC current to AC so that you can export it direct from the grid. Now, the problem is that when you have a shading event or something, you drop from the blue curve down onto the red. And microinverters will mean that the panel that's been affected, or the other panels in the string, are able to be optimized to where they are on that red curve. Now, the problem is, though, that because the voltage drop has occurred, you've got that higher resistance, they can't do anything other than move you along this red curve. By introducing additional voltage back into the panels, though, we take you back up to the blue curve. So they can optimize within the IV curve, but they can't take you back to the operating point that you were basically at before, which is what we can do with OptiCell.
Fantastic. Garth, that's brought us to time, but there's a really good question in the chat box for you, a real technical one that Arnie has asked. So please, I invite you to dive into that question. I'll give you a few minutes to answer that as well. Garth, thank you so much.
No, thanks, everyone.
Fantastic. So that brings us to the end of the showcase part of today. Unfortunately, Anaxium was not able to showcase with us today. Tia's not well at the moment, but please do reach out to learn more about Anaxium. Their patented technology harnesses low-grade waste heat to decarbonize wastewater treatment, replacing emission-intensive cooling systems in green hydrogen production, manufacturing, data center cooling, and mineral extraction. They have some really exciting traction at the moment as well. So please do reach out if you want to learn more. So thank you so much to everyone for joining today. It's been an absolute pleasure to showcase the founders of the 2024 Climate Solutions Accelerator. I'm sure you're all feeling a fresh wave of optimism around how we're moving towards reaching our decarbonisation goals. So this marks the end of the Accelerator program for the year, which means that before too long, we will be opening up applications for our 2025 intake. So if you are a brilliant founder ready to scale your climate solution amongst a great group of founders, or you know someone who is, please send them our way. If you are an investor or have been really impressed by this group, reach out to learn more about how you could join our angel group and also invest in our Accelerator fund. If you think that you can support these startups in any other way or would like to connect with them, please do reach out to them over LinkedIn or to myself. All connections are welcomed. Please visit our website to learn more. And thank you once again and enjoy the rest of your day.